Hey guys, so this is going to be the third video on implicit differentiation. I created a third video because this problem will be longer, just all by itself. Notice that the instructions don't ask for dy over dx, but rather the second derivative. So we'll be deriving this function twice. So let's get started on this. Now, the first time we derive it, nothing we haven't done before. We've also done a similar problem to this. So I'm just going to derive x squared, which would give me 2x, plus y squared, which would be 2y. And again, I'm going to note dy over dx equals, you also derive the other side. The derivative of any constant, which in this case 25, would be 0. So now that we're done, our goal is just to do what we did last time and isolate dy over dx. Notice it's being multiplied to 2y and it's being added to 2x. Remember, the sign is always to the left of the number. So to start it off, I'm going to subtract 2x to both sides of the equal sign. Remember the lovely algebra saying, whatever you do to one side, you do to the other. So 2y times dy over dx equals 0 minus 2x, which is negative 2x. Okay, so one last step to get dy over dx by itself. It's being multiplied to 2y, so I'm going to divide both sides by 2y. And what I have here is dy over dx equals, notice how the 2's divide out, and I'm left with negative x over y. I am going to box this because we will need to remember this. So we are moving on to the second derivative, so we're going to derive it again. To derive this again, first of all, I'm going to bring up what we had, which is dy over dx equals negative x over y. We're dividing two different variables, so to derive this, I'm going to use the quotient rule. So let me note down what f is and what g is. And then remember that the quotient rule, I have to find f prime and g prime. Well, f prime, negative x would be negative 1 times 1, which would be negative 1. And then if I take 1 away from the power, it would give me x to the 0 power, which I don't need to write down. And then the derivative of y, again, 1 times 1 is 1, and I don't need to write y to the 0 power, so that would be 1. But since I derived y, I'll also note dy over dx. So to find the second derivative, I am deriving this again, and I'm using the quotient rule to do so. So remember the quotient rule, gf prime minus fg prime over g squared. So I'm going to plug in what I have. So I'm going to replace the g with y to the first power. You don't have to write to the first power, by the way. And then it's multiplied to f prime, which is negative 1. So negative 1 times y is negative 1y. I'm just going to write negative y. And then minus fg prime. So f is negative x, and it's being multiplied to g prime, which is 1, which I'm not going to write down, and dy over dx. All over g squared. It looks messy right now, but we're just going to clean it up afterwards. And I'm going to erase that 1 just because I keep thinking it's prime. Okay, so now to clean this up a little bit, we have negative y. We know that the minus and negative will give me plus x dy over dx over y squared. So remember that time I had you box in what dy over dx is. Reason for that, I don't want to keep anything in terms of dy over dx for the second derivative, so what I'm going to do is I'm going to replace dy over dx with what I know it equals to, which is negative x over y. And isn't that very convenient that I've run out of room? So I'm going to rewrite this function, just replacing the dy over dx with negative x over y. So moving on to the next slide. Remember, this is going to be the second derivative that I'm looking for equals, and what I had here was negative y plus x. Well, I'm going to write the whole thing just so, I don't lose you guys. And then we noted that dy over dx equals negative x over y. Okay, so I'm going to rewrite this now. So dy over dx is negative x over y. Everything else I'm going to bring down. So equals negative y plus x over y squared. And from here, I'm going to apply PEMDAS. Multiply before you add. In this case, if I multiply straight across, I'm going to get x times negative x, which is negative x squared, over y times 1, which is y. Everything else, again, bring over. I'm not going to write the plus and negative, so it's just minus over y squared. So I have negative y minus x squared over y squared. I'm going to focus on this. We don't have parentheses or like a fraction over a fraction. That's just tacky. So remember, once upon a time, I taught most of you how to add and subtract fractions. You can always use common denominator, but I use another method, crisscross applesauce, always left and down first. Negative y times y is negative y squared. Minus, because there's a minus in the middle. And then, so that would be criss and now cross. 1 times x squared is x squared over applesauce. Y times 1 is y. So I always use that method, and you can use it for adding fractions as well as subtracting fractions. Always left and down first, because that matters for the order of subtracting fractions. Left and down first, criss, cross, over applesauce. And then I'm going to bring down the over y squared. So I still have my fraction over a fraction, but once you simplify it by adding and subtracting, whatever needs to be done, now you can actually divide the fraction by applying keep, change, flip. So that means we keep the first fraction, which is negative y squared minus x squared over y. Change, we change the division into multiplication. And flip. So the fraction form of y squared is y squared over 1. I'm going to flip it, and I'll get 1 over y squared. So keep, change, flip, and then we multiply fractions straight across. So adding and subtracting fractions, crisscross applesauce. To multiply fractions, we go straight across. So anything with plus or minus sign should be in parentheses so we can multiply straight across properly. I'm multiplying each one of these terms by 1, which I get it doesn't really make a difference, but just in case it wasn't actually 1, that gives me negative y squared minus x squared over, multiply straight across the denominator. Remember, when we multiply, we add the exponents. So y times y squared would give me y to the third power. Multiplying like bases, you add the exponents. So this would be my second derivative. Remember, that's what it equaled to the whole time. All right, guys, I hope this helps.